Hello students, today we will solve numericals on Routh stability criteria. Okay, so let's see. First numerical is determine the range of k for stable operation. Okay, see here what is given. Here it is given you need to find the range of k for stable operation. Here it is given that system is stable. Okay, so please revise the concept. Here it is given that system is stable. When we are saying that system is stable, so first column in Routh array, it should be positive. Then only we can say that system is stable. Okay, so here it is given that it is stable and you need to find the range of k. Okay, now look at this. Here actually this is actually g of s. Okay, and h of s is unity feedback. So for Routh array we need a characteristic equation. So what we will do, we know that characteristic equation is given by 1 plus g of s into h of s is equal to 0. Okay, so we will substitute the value of g of s, h of s here. G of s is s square plus s plus 1 into s plus 4. This is g of s. Okay, and h of s is 1 is equal to 0. So I will rearrange this and I will get a characteristic equation. Okay, so look at this. Now the characteristic equation, it will be s cube plus s square plus s, and we need to multiply it again with s plus 4 plus k is equal to 0. Okay, so I got the characteristic equation as, now I am writing in final form as I have the characteristic equation. Okay, so look at this. Here characteristic equation will be s raised to power 4 plus 5s cube plus 5s square plus 4s plus k is equal to 0. Okay, so now this is the characteristic equation. Okay, so what I will do, I will arrange this characteristic equation in Routh array. Okay, so highest power of s is here s raised to power 4. Then see here this will be s cube. Okay, so next is s square, next is s raised to power 1, and last will be s raised to power 0. Okay, so look at this, how you will get the Routh array. We know that the elements from first row of the Routh array that we have to obtain from characteristic equation. So I will start with this coefficient of s raised to power 4. I will skip one term, then it will be 5. Okay, skip one term, then it will be k. Now next start with this s cube. So what is coefficient of s cube is 5. Okay, skip one term, it will be 4. After 4 skip one term, no term, so it will be 0. Okay, so now look at this. Here this will be 25 minus 4, so it will be 21 by 5. Okay, 25 minus 4 into 1, so 25 minus 4 divided by 5. Here it will be 5k minus 0 by 5. Okay, so I am writing 5k by 5, it will be k. Okay, now look at this. Last we know that s raised to power 0, we have to put the coefficient of s raised to power 0. So here coefficient of s raised to power 0 is actually k. Okay, again I need to multiply this into this minus 5k upon this term. Okay, so what we are getting here, look at this, this 21.5 is actually 4.2. Okay, so I am getting 16.8 minus 5k upon 4.2, because this 21.5 is nothing but 4.2. Okay, so this term. Okay, so look at this now. What we will do, here we need to find the range of k. Okay, so consider the first column of Routh array. For system to be stable, all elements in first column of Routh array should be positive. Okay, So we will consider the first column of Routh array. Look at this is positive, 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 okay, and we need to check for this term. So 16.8 minus 5k upon 4.2, for system to be stable, this term should be greater than 0. So 16.8, okay, is greater than 5k, okay, so k is less than 3.36, okay. So you have to write answer range of k. Range of k will be 0 less than k less than 3.36, okay, 0 less than k less than 3.36, okay. So this is answer or range of k for the given equation, okay. Now we will see the next numerical, okay. So see here what you need to find. Here the second characteristic equation is given, and in this characteristic equation you have to comment on the stability, means you have to calculate the stability, okay. In previous numerical, system is stable and you have to calculate the range of k. Here you have to comment on the stability, okay. So we know that for higher order system we have to use Routh array. We will not go for the Hurwitz's criteria, okay. So we will start to form the Routh array. So I will start with this s raised to power 6, s raised to power 5 first, okay. Now start with this coefficient of s raised to power 6, 1, skip one term, 5, skip one term, then add, skip 1, 4, okay. Then start with this 3, skip one term, 9, then skip one term, it will be x, next it will be 0, okay. So s raised to power 4, we know that 9, this will be 15 minus 9 upon 3, okay. I'm writing here 15 minus 9 upon 3, okay. This will be 24 minus, look at this, 24 minus 6 upon 3. I'm considering the first column as it is, okay. Now next is here 12 minus 0 upon 3 and last will be 0, okay. So I'm directly writing the values here, okay. So I'm getting here, see, actually I'm writing values, so I will use pen here. So this is actually 2, 6 and 4, okay. Now see here, we need to find the next coefficient for s cube, okay. So what I will do, look at this, here it will be 9 2s are 18 minus 6 3s are 18, so 18 minus 18 upon 2. Here also you can check 6 2s are 12 minus 4 3s are 12, so 12 minus 12 upon 2, and next it will be again 0, okay. So what exactly we are getting here? Here we are getting actually the 0th row. Look at this, this is 0th row, okay. So when any row in Routh array is 0, so we have to apply special case 1, okay. So sorry, special case 2. So what we need to do here, we have to obtain the auxiliary equation, okay. So I will write here, what is auxiliary equation? For auxiliary equation, I have to consider the row just above the 0th row. Look at this, I have to consider the row just above the 0th row, okay. So I will form the auxiliary equation like this, look at this, 2s raised to power 4, 2s raised to power 4, I will skip one term, then it will be 6s square, okay. Again I will skip one term, plus 4. So this will be my auxiliary equation. Next I need to calculate the derivative of this auxiliary equation, okay. So this will be 8s cube plus 12s, okay. So we know that what we are doing, we are replacing the 0th row with this row, okay. So what I will do, I will replace this 0th row, okay. So see, actually you can rewrite the row or rewrite the Routh array also, okay. So what I am doing here, I am directly showing here s cube. What I will do, I am replacing that 0th term with this. So this will be now 8, 12, okay. So again I need to complete this. So s square, it will be 48 minus 24 divided by 8, and this will be 32, okay, minus 2 divided by 8. So I am just putting the value here. So this is 3, 4, s raised to power 1, I am getting 4 by 3, and last is s raised to power 0. So look at this, s raised to power 0 term is actually 4. Okay, so see, actually for Routh array or for commenting on the stability, I need to consider the first column of Routh array. So look at this, here there are no sign changes, all the terms in first column of Routh array is positive. Okay, so what you will say that system will be stable. So I will write here system is stable. Okay, but see, I told you that in special case 2, system is stable because of this condition. Okay, so this is actually the conditional stability. What I will say, I have replaced this term with the coefficient of the derivative equation. Okay, so I need to find the roots there. So how I will find the roots there? Look at this here, auxiliary equation a of s, I know that 2s raised to power 4 6s square plus 4 is equal to 0. So we have already solved like that. S square I will consider as a y. Okay, so what I will do, I will write 2y square plus 6y plus 4. Okay, so I need to find the value of y here. Okay, so I have the answer that I am writing here. So I am getting y as minus 1 minus 2. Okay, so I know that s square is equal to minus 1 and second as s square is equal to minus 2. So s I am getting that plus minus under root of 1j. Okay, and here I am getting as s is equal to, this is actually minus 2, so plus minus j under root of 2. Okay, so see what actually I am getting here, I am getting the imaginary roots. Okay, I am getting the imaginary roots. So I know that when the roots are imaginary, look at this, when the roots are imaginary, you can check that here real part is 0, roots are imaginary, system is marginally stable. Okay, system is marginally stable. Okay, so instead of writing here system is stable, but as we have calculated the imaginary roots, so we know that system is marginally stable. Okay, so I hope you got the concept. Okay, so see, we have solved 2 numerical based on the Routh stability criteria. Okay, so we will solve more numericals on the Routh stability criteria. Thank you, students.